All right, welcome back to lab, everyone. So this is the intro for lab number 6. So this lab is actually fairly straightforward, fairly easy. So we only have really one concept to talk about. And this is mostly getting us ready for the next portion of the class after we take this next exam, which has to do with circuits, getting us to what's known as Kirchhoff's loop rules. But this part of it's just what's known as the loop rule. So basically what this says is we're going to be creating simple circuits. So here I have a battery. Now the point of the battery is to supply energy by doing work. And what it does is it forces the charge carriers to move through the circuit. So typically we like to think of positive charges. So what this thing does is it forces positive charges of charge Q to move away from the positive terminal via the Coulomb repulsion, and then be drawn through the circuit back into the negative terminal, and then just keep moving through here. So the point of this is to actually supply energy from the battery. So this is what's called battery, and this supplies energy. So supplies energy. Then as the system goes around, what conservation of energy tells us is that what? If I start at a point A and I go through my system and I get back to the same point A, I better have the same amount of energy at which I started with. Which means that if this thing is supplying energy, I have to have something in here which is actually getting rid of the energy, which is dissipating the energy, which is the point of the resistor, or in this case, our light bulb. So our light bulb is what's known as a resistor. And the point of this thing is to actually drop energy, or to lose energy. So that by conservation of energy, if I start here, if I go through, I lose energy here, I come through, I gain the same amount of energy here, I end up at point A, then I have to have exactly the same amount of energy. So again, conservation of energy tells me that if I start up at point A, I go around through the circuit, the change in energy has to then be equal to simply 0. Now, as we learned in last lab, we can actually define a new quantity, which is called the potential, or in this case, the potential difference, the change of potential, which is then equal to the change of potential energy per unit charge, which means that the change in energy is equal to 0, therefore the change of potential must be equal to 0 as well. Okay, so that's basically what has to be true. So, like I said, this is actually what's known as the loop rule. So, in this lab, the first part of the lab is mostly, again, getting used to kind of our voltmeters and all that good stuff. But then the second part is we're going to be making simple circuits. So here's an example of a simple circuit. So here I have a battery, which is attached to a harness, just make it easier to actually connect my wires. So I actually have something to grab onto. So this is my positive terminal, my negative terminal, and then to here we're going to connect some wires, and then I'm going to connect my resistor or my light bulb. Okay. So basically, all I'm going to do is clip this guy out of here, and then you should see the light bulb come on, okay, as it's doing here. Now, if the light bulb doesn't come on, that means typically one of a couple things. Number one is your battery could be dead, meaning you have no potential difference, or at least not enough potential difference to create enough current in here to cause the light bulb to light, or there's something wrong with your wires. So basically what will happen is inside of here, this piece of wire will be connected to the alligator clip. So if that's kind of ripped off, then you're actually not going to measure anything. So this is the first one. The second one we're going to do is involving, I think, 2 light bulbs and 2 batteries. That'll be the last part. But basically what you want to do from here is then measure the round trip potential difference. So what that means then is, let me prop this up a little bit higher so you can see it. There we go. So basically, all we're going to do then is we're going to measure the potential difference across each one of these objects. Now, when you're measuring the potential difference, first thing you want to make sure is that you keep your wires in the same order, which means that, for example, if I measure the battery across here, there we go. So I'm measuring it, so that means that I have the black one at the front, at the positive terminal, the red one at the back, so the negative terminal, and this is telling me I have a potential difference of 1.43. Okay. Now, when I go to the next thing I want to measure, which is the potential difference across the wire, I have to make sure that since this one was in the front and this one was in the back, this one is still in the front and this one is still in the back. So now when I measure here, I'm going to put one on this side and then one on this side, and I'm going to measure a potential difference of negative 0.03. So that negative is important because it means that I'm losing potential or losing energy in the wire itself. Now then, when I move to the next piece, again, I want to measure across the resistor, so I have to put the black one first and then the red one. So now I have a negative 1.37 potential drop. And then finally, I'm going to move the red one to here, move the black one back here, and now I have a negative 0.02 potential drop. So you're just going to record all of those potential drops and then simply sum them all together. So I have a positive one here, negative, negative, and negative, which means that if I add all those together, I should theoretically get 0 based off of the loop rule, i.e. based off of conservation of energy. Now, what you'll find in most cases is that you don't actually get 0, and the reason for that is a couple things. Number one, there's an inherent uncertainty inside of our voltmeter, which means that this thing is reading a voltage up to plus or minus something. I forget exactly what the plus or minuses are of the voltmeter, but there is some inherent uncertainty in the amount at which you're actually measuring. The other thing is, because you're only going to 2 decimal places, when I measured something like 0.02 or negative 0.02, it actually might be something more like negative 0.01895, blah, 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 which means that it's not exactly that particular number that you're writing down, it's rounded up to that particular decimal places. So there's 2 places of error that basically shows up here. Again, one is due to rounding, and the other place is because there's an inherent uncertainty in this anyways. So when you go through and you measure the potential here, again, through the wire, across the resistor, through the next wire, if you add them all up, it may not equal to 0. So just don't be worried if it doesn't, because again, there is inherent uncertainty in it, and there's also, again, there's rounding issues. So if you go out to further decimal places and take the error into account, then you should be able to get 0 in these cases. But again, this is what's known as a loop rule, which just comes from conservation of energy. So again, it just says that if I make a round trip, starting at say point A, I do a round trip across this simple circuit. Again, the battery supplies energy, the wires and the resistor itself both lose energy, so that if I get back to that round trip position, I have to have 0 net loss and 0 net gain, so I have to have 0 change in potential energy, which means that I have to have 0 change in potential. Or it means the potential difference between point A and point A is equal to 0, which it should be, because it should be at exactly the same potential at all times. So again, as far as Kirchhoff's loop rules are concerned, this is the first portion of Kirchhoff's loop rules. We'll discuss the rest as we actually go through. But that's it. So the first part is, like I said, you're basically going to be playing with, again, getting used to your voltmeter. So you're measuring potential across the battery, playing with other things, checking the settings, etc. And then after that, you'll make this simple circuit that I made here. And then in the last part, you'll make a simple circuit with 2 batteries as well as 2 light bulbs. And again, just measure the round trip potential. Again, in theory, they should be equal to 0, but in practice, they probably won't be because of those things that we discussed a little bit ago. So that's it. That's all we're going to do in the lab.